Have a look at that beautiful plot. We've got some original images and some transformed images. And the beautiful thing about our transformed images is that they're in tensor format, which is what we need for our model. That's what we've been slowly working towards. We've got a data set, and now we've got a way to turn it into tensors, ready for a model. So let's just visualize what another... I'll turn the seed off here so we can look at some more random images. There we go. Okay, so we've got steak. Pixelated because we're downsizing 64:64:3. Same thing for this one, and it's been flipped on the horizontal. And then same thing for this pizza image, and we'll do one more to finish off. Wonderful. So that is the premise of transforms, turning our images into tensors and also manipulating those images if we want to. So let's get rid of this. I'm going to make another heading. We're up to section or part 4 now, and this is going to be option 1. So loading image data using ImageFolder. And now I'm going to turn that into Markdown. And so let's go Torch Vision datasets. So recall how each one of the Torch Vision domain libraries has its own datasets module that has built-in functions for helping you load data. In this case, we have an image folder, and there's a few others here if you'd like to look into those. But an image folder, this class is going to help us load in data that is in this format, the generic image classification format. So this is a pre-built datasets function. Just like there's pre-built datasets, we can use pre-built dataset functions. Now, option 2 later on, this is a spoiler, is we're going to create our own custom version of a dataset loader, but we'll see that in a later video. So let's see how we can use ImageFolder to load all of our custom data, our custom images, into tensors. So this is where the transform is going to come in helpful. So let's write here, we can load image classification data using, let's write this. Let's write the full path name, torchvision.datasets.imageFolder. Put that in there. Beautiful. And so let's just start it out. Use ImageFolder to create datasets. And now in a previous video, I hinted at the fact that we can pass a transform to our ImageFolder class. That's going to be right here. So let's see what that looks like in practice. So from Torch Vision, I'm going to import datasets because that's where the ImageFolder module lives. And then we can go train data equals datasets.imageFolder. And we're going to pass in the root, which is our train dir, because we're going to do it for the training directory first. And then we're going to pass in a transform, which is going to be equal to our data transform. And then we're going to pass in a target transform, but we're going to leave this as none, which is the default, I believe. If we go up to here, yeah, target transform is optional. So what this means is this is going to be a transform for the data, and this is going to be a transform for the label / target. PyTorch likes to use target, I like to use label, but that's okay. So this means that we don't need a target transform because our labels are going to be inferred by the target directory where the images live. So our pizza images are in this directory and they're going to have pizza as the label because our data set is in standard image classification format. Now, if your data set wasn't in standard image classification format, you might use a different data loader here. A lot of them will have a transform for the data. So this transform is going to run our images, whatever images are loaded from these folders, through this transform that we've created here. It's going to resize them, randomly flip them on the horizontal, and then turn them into tensors, which is exactly how we want them for our PyTorch models. And if we wanted to transform the labels in some way, shape, or form, we could pass in a target transform here. But in our case, we don't need to transform the labels. So let's now do the same thing for the test data. And so that's why I wanted to visualize our transforms in the previous videos, because otherwise we're just passing them in as a transform. So really what's going to happen behind the scenes is all of our images are going to go through these steps. And so that's what they're going to look like when we turn them into a data set. So let's create the tester here, or the test data set. The transform, we're going to transform the test data set in the same way we've transformed our training data set. And we're just going to leave that like that. So let's now print out what our data sets look like. Train data and test data. Beautiful. So we have a data set, a torch data set, which is an image folder, and we have number of data points. This is going to be for the training data set. We have 225, so that means about 75 images per class. And we have the root location, which is the folder we've loaded them in from, which is our training directory. We've set these two up before, traindir and testdir. And then we have a transform here, which is a standard transform, a resize, followed by a random horizontal flip, followed by toTensor. Then we've got basically the same output here for our test directory, except we have less samples there. So let's get a few little attributes from the image folder. This is one of the benefits of using a PyTorch pre-built data loader, or dataset loader, is that it comes with a fair few attributes. So we could go to the documentation, find this out from in here, inherits from dataset folder, keep digging into there, or we could just come straight into Google Colab. Let's go get class names as a list. Can we go train data dot and then press tab? Beautiful. So we've got a fair few things here that are attributes. Let's have a look at classes. This is going to give us a list of the class names. Class names. This is very helpful later on. So we've got pizza, steak, sushi. We're trying to do everything with code here. So if we have this attribute of traindata.classes, we can use this list later on for when we plot images straight from our data set or make predictions on them and we want to label them. You can also get class names as a dictionary mapped to their integer index, that is. So we can go train data dot and press tab. We've got class to IDX. Let's see what this looks like. Class dict. Wonderful. So then we've got our string class names mapped to their integer. So we've got pizza is 0, steak is 1, sushi is 2. Now, this is where the target transform would come into play. If you wanted to transform these labels here in some way, shape, or form, you could pass a transform into here. And then if we keep going, let's check the lengths of what's going on. Check the lengths of our data set. So we've seen this before, but this is going to just give us how many samples that we have. Length, train data, length, test data. Beautiful. And then of course, if you'd like to explore more attributes, you can go train data dot, and then we've got a few other things, functions, images, loader, samples, targets. If you wanted to just see the images, you can go dot samples. If you wanted to see just the labels, you can go dot targets. This is going to be all of our labels. Look at that. And I believe they're going to be in order. So we're going to have 0, 0, 0, 1, 1, 1, 2, 2, 2. And then if we wanted to have a look, let's say we have a look at the first sample, hey? We have data, pizza, steak, sushi, train, pizza. There's the image path, and it's a label 0 for pizza. Wonderful. So now we've done that, how about we've been visualizing this whole time. So let's keep up that trend. And let's visualize a sample and a label from the train data dataset. So in this video, we've used ImageFolder to load our images into Tensors. And because our data is already in standard image classification format, we can use one of TorchVision.dataset's pre-built functions. So let's do some more visualization in the next video. I'll see you there.